Welcome to this explainer. Today, we're tearing down the old ways of building React applications and looking at a true game changer. Listen, if you've ever felt completely overwhelmed by data fetching, endless loading spinners, and those completely impossible to reproduce cache bugs, you are absolutely in the right place. We're going to master TanStack Query v5, which is, without a doubt, the ultimate solution for server state management in React. Seriously, we're going to completely transform how you write your apps.
Okay, let's dive into our agenda for today. We'll start with number 1, the server state problem. Then 2, setup and core concepts. 3, fetching with useQuery. 4, mastering the cache. 5, mutations and cache updates. And finally, 6, a best practices recap. Let's get right into it.
To really appreciate the solution, we first need to understand the problem. Let's look at section 1, the server state problem, and exactly why your data is constantly going stale.
Think about it like this. Client state, like a dark mode toggle handled by zoostand or Redux, is yours. It's totally predictable, it's local. You own it, lock, stock, and barrel. But server state, that's a whole different beast. You don't own it, you just borrow it. It lives remotely, somewhere in a database. It requires asynchronous APIs just to access it, and crucially, other users can change it without your application ever knowing. And what does that mean for you? It means your borrowed data is constantly, silently going stale right under your nose.
If you've been building React apps for a while, you intimately know the pain of trying to manage this borrowed state manually. You end up writing dozens of lines of bug-prone useEffect and useState boilerplate just to fetch a simple list of items. You're constantly juggling manual loading flags, handling errors, and accidentally causing duplicate network requests if two components happen to mount at the exact same time. Not to mention fighting nasty race conditions. It's a mess, and frankly, most hand-rolled server state ends up getting this wrong.
So how do we actually fix this? Well, we stop managing server state ourselves. Let's pivot to section 2, setup and core concepts, where we'll lay the foundation.
The setup is surprisingly simple, just 3 easy steps. First, you install the package. Second, you create a new instance of a query client. And third, you wrap your entire app in a QueryClientProvider. Now, you could literally name your client variable pizza. It honestly doesn't matter. But functionally, this client acts as the global brain for your entire application's data.
As our source material perfectly puts it, providing this client at the top level is exactly what allows any component in your app to access the shared memory mechanism. You get this incredibly powerful global caching without having to do any prop drilling whatsoever. It's all just there, waiting for you.
With that foundation laid, let's move right into section 3, fetching with useQuery. Get ready, because this hook is about to become your new best friend. Just by calling useQuery, we automatically destructure exactly what we need for our UI. We get the data itself, an isPending flag if there's no data yet, and an isError flag if things go sideways. This instantly deletes massive amounts of that boilerplate we talked about earlier. But pay super close attention to this bottom point, because it's a game changer. TanStack Query actually separates your data state from your network state. Status tells you about the data itself, like do we currently have it in hand or not. Meanwhile, fetch status tells you about the network. Is a request actively running right now? This means a query can have a perfectly successful data status while simultaneously having an active fetching status. It's just silently updating your existing data in the background.
Now, to actually make useQuery work, you really only need 2 things. A query function that fetches the data, and crucially, a query key. So what is a query key? It's the unique identifier for your data in the cache. It's always an array, and the order of the items in this array matters immensely, because TanStack Query hashes it deterministically to manage your memory under the hood. The golden rule of thumb here is to always structure your query keys hierarchically, going from the most generic to the most specific. For example, a generic list of to-dos might just be an array with the string to-dos. A specific to-do item would be the string to-dos followed by its specific ID. This hierarchical design is absolutely vital. Why? Because it makes it incredibly easy to target and invalidate whole groups of related data later on.
All right, now we reach the most critical part of this explainer, section 4, mastering the cache, where we visualize the invisible. This is what separates the beginners from the experts. Now, what's really interesting about this slide, and you'll want to lock this in your memory, is the clear distinction between staleTime and gcTime. By the way, gcTime used to be called cache time in older versions. Mixing these two up is the #1 source of developer confusion. staleTime controls exactly when your data is considered out of date and needs to be refetched in the background. On the other hand, gcTime, or garbage collection time, controls how long completely unused data actually sits around in memory before it is permanently deleted to free up resources.
Look at this number right here, 0. Notice that by default, stale time is exactly 0 milliseconds. Think about what that means. It means the very second you fetch data, TanStack Query immediately considers it stale. Therefore, out of the box, your app is configured to constantly pull fresh data in the background anytime a window is refocused or a component mounts.
Because of this 0 millisecond default, TanStack Query operates on what we call a stale while revalidate pattern. It's brilliant. Imagine you're clicking between a home page and an about page. The very first time you visit the about page, sure, you get a loading spinner. But when you click back to it later, no spinner. You instantly see the cached data. Meanwhile, the network is silently fetching the absolute freshest copy in the background and updates the UI without the user even noticing. You get this instant, snappy, cache-based display, but you are guaranteed to always be looking at the freshest data.
Now that we've mastered reading data, let's transition to writing data. Section 5, Mutations and Cache Updates.
So here's a big question. How do we cleanly handle creates, updates, and deletes now that we've totally abandoned our manual uEffect fetches? We need a way to change things, right? This brings us to the counterpart of queries, mutations. Enter the useMutation hook. This is designed for literally any operation that changes data on the server. The fundamental difference you need to grasp here is that while queries run automatically based on their query keys being active, a mutation is a completely manual action. It will only ever fire when you explicitly call its mutate function, say, when a user clicks a submit button.
Here is the exact step-by-step lifecycle of how you keep your app perfectly in sync when you change data. First, your useMutation function fires off to the server. Second, if the server says, "Yep, that worked," the onSuccess callback triggers. Third, inside that callback, you use QueryClient.invalidateQueries and pass in your hierarchical query key, like our generic toDo's key. Because you structured your keys from generic to specific, marking toDo's as stale tells TanStack Query that the whole list is now bad. And fourth, any component currently looking at that list automatically performs a background refetch to grab the newly updated data. It's a beautiful, seamless loop.
So the crucial point is that while simply invalidating queries is the easiest and most common way to refresh your data, you actually have some really powerful advanced options. You can perform a direct cache update. This means instead of making a whole new network request to fetch the updated list, you simply take the server's mutation response and inject it straight into the cache yourself. Or, if you want a truly instant-feeling UI, you can use optimistic updates. This is where you actually update the user's screen before the server even confirms the change. And the best part, if the network fails for some reason, TanStack Query automatically rolls the UI back to its previous state. It's like magic.
Wow, okay, we have covered a massive amount of ground today. Let's enter Section 6, Best Practices Recap, tying it all together. Here is your ultimate mastery checklist. 1. Absolutely always keep those query keys hierarchical, going from generic to specific, so that invalidating data is a total breeze. 2. Tune your stale time. Don't leave it at 0 if your data only changes once a year. Set it to a half hour or whatever makes sense to eliminate unnecessary network chatter. 3. Prefer invalidate queries for its sheer simplicity unless you absolutely need the blazing speed of optimistic updates. And 4. Always install and use the TanStack Query Devtools. Being able to visually inspect exactly what is stale, fetching, or inactive in your cache is quite literally like having a developer superpower. Remember, these simple declarative practices are replacing massive amounts of buggy, handwritten code.
I want you to think about your current codebase for a second. Think about all those messy useEffect hooks, the endless loading flags, and the weird race conditions hiding in your app right now. Are you ready to just delete thousands of lines of manual logic and finally let your server state manage itself? Dive into TanStack Query v5, apply the principles we covered today, and experience the magic for yourself. Thanks for joining this explainer, and happy coding.